thank you for coming back to part 2. So I see here enough people still, so I'm quite pleased about this. I know the first part was quite intense for you, and there's a lot of information there, but what we try to do as well is that we give you the tools now in the first 2 parts. In the third part, or the basic understanding, in the third part you actually have some hands-on exercise. This will basically then bring the things together, and you will really go through some exercises to understand how to use the test bed. And then you have the whole week to work on your own experiment then, or your set of experiments that you can present later as a teamwork. So although this may now be a lot of information, I think through the week, once you start playing with it, it will become, I think, more digestible for it. Okay. So the second part looks really like at the experimentation on Santander. We have basically like 3 basic learning goals. The one is basically just to understand what is a typical IoT experimentation lifecycle, and then also to get an understanding of what are the different tools that the experimental facility offers you to basically help you through this process. And then also one part which is quite interesting to see is if you do also user-centric experimentation, there are other dimensions apart from the test bed that you have to consider. And I have a few thoughts on this as well that could be helpful later if you want to involve users in the experiment. So based on this, we have also very, very clear structure. So the first one just looks a little bit about the typical, examines this typical experimentation life cycle. And then we look at 3 tools. One is Timon, that is basically a tool that has been developed by the University of Surrey, which works on the testbed of Surrey and in the Lübeck testbed. And the second one is the WISE GUI, which is another web-based tool. So the first one is a Java-based tool, the second one is a web-based tool, which also allows you to access the testbeds through like a web browser type of interface. And I think this is the one that's mainly used in Lübeck and Santander itself. And then there's a third tool, which is basically it's more experimental scripting, right? So if you want to run maybe more a series of automated experiments, and you don't want to be always connected with, let's say, a user interface or something like this, you can also use the scripting tools for this. And Daniel will be covering the other 2 parts before I then come back on this user-centric experimentation. Okay, so let's dive straight into it. I don't know, how many of you have already done some experiments already, like on an IoT testbed? And 1, 2, 3. So not too many people. Okay, so okay, then you won't be bored when I explain this. So a typical experimentation life cycle, you can somehow look at 3 main phases. So the first one is the specification phase, where you basically need to kind of design your experiment and understand what you need to collect in terms of data and statistics, where you get an understanding of what kind of testbed resources you need and so on for your experiment, and where you provision basically all the necessary code or logic that you need for the experiment execution. And that's already a quite intensive process. So it's a phase which is basically quite a lot at the beginning, which you may have to run through a few cycles until you come up with, at some point, your final type of experiment where you can run on a larger scale and maybe get a bit more intense data. But it's something that is kind of instrumental to the whole experimentation process. Then the setup phase is something where you start interacting with the testbed more, like in terms of the resources themselves. You can reserve, schedule resources, and deploy your experiment. And then there's the last one, which is the execution phase, where you actually run the experiment live, and you can also interact during the time with the testbed itself. And in the execution phase is where you actually get all, let's say, your experimental data collected, or logging information. So at the beginning it will be maybe more here, like some debugging first of your thing. Yeah? So it's more like trying to reach a certain maturity of your experimentation code. Whereas then in later phases, you can actually get real results that you can use for analysis and so on. And then obviously I haven't mentioned explicitly there, but there's also another phase which is like data analysis, where you really have to understand your data, interpret your data, make sense out of it. And for this, you can use partially a bit the experimental tools that we have in some of the environments, but it's mainly also stuff that you do with MATLAB, or you do with other, let's say, number crunching tools that, that you are familiar with in your research. Okay, that's just an example process. I know it's a bit intense from the font size, but in essence, the normal way is like you specify an experiment, you design it, you know, then it's a very big crucial point. Do you need to involve end users or not in this experiment? Is it one that just relies on technology, or is it one where users play a role in it? And if users play a role in it, another chain of things you have to consider. This is something I will talk about later. But in the case you're lucky, you don't have to involve users. It's just about then deploying, executing your experiment, collecting your data, analyzing your data. So that is kind of the typical flow. And I said, the user-centric part is something I will cover in the third part of this session. So the first phase is like specifying your experiment. Okay? So what is actually the goal of your experiment? What do you want to evaluate? This is something that you have to clearly define. Is it testing like a protocol solution? Is it testing a service? Do you want to just understand, collect some traces of real-world interactions that you want to use later for some simulations? I mean, there are different objectives that you can have for experiments, and you have to be very clear about these objectives. What is what you want? Also, you need to understand what are adequate scenarios where you want to do this data collection, or what's the environment where you want to host your experiment in. And as you say, SmartSantander has different testbed sites. In each of them, they'll influence maybe which ones you're going to select for in the end. Is it something that you want to run in an indoor, like in a building type of office scenario? Then, for instance, the Gluhak testbed is a good facility for it. But if it's like you want to have some form of, let's say, information from buses or traffic patterns or whatever in the city, then maybe the Senzations testbed site is more useful for you. So there are this type of decisions that you have to do and make before you actually start, doing something with the facility. What are the different indicators that you want to collect or measure during your experiments? Is this basically maybe you maybe, for instance, wanting to design a routing protocol, you want to measure maybe the end-to-end delay that your packets experience when they travel to the network, the packet loss. What are the factors that you want to, what are the statistics that you want to collect? These are things that you have to kind of think about and design when you build into your experiment when you build it. Then also, is it stuff where I actually need to modify functions on the sensor nodes themselves? So is it more like the system level type of experiments I want to run, or is it just service level where I'm just interested in data? So these are things that you have to kind of think about. And finally also, do I need to involve end users? Are they a critical part of it? And then you have to trigger you need to deal with users in terms of ethics approval. You need to also recruit participants and so on. So it's a whole chain of new things that you have to take into account. Then a second part is, once you know about all these scenarios, then what are the best experimentation resources? So in terms of the scale, in terms of the devices that you need, or information flows, in terms of the capabilities, the topology, these are all factors that will influence your experiment at the end. And also, it's important basically that you understand what are these topologies, what are these characteristics that the different testbeds offer. And we have some tools that can support you with this, so to make these kind of decisions. And I will show them in a bit of time. Also, although there may be, let's say, nice resources, the ideal resources available for your experiment, they may not be available currently because someone else is using them. So it could be that the usage is like for 1 or 2 days, but it could be as well that they are blocked out for an entire month. And this will again influence your design of the experiment and also the capabilities that you have on offer. And you may want to maybe run or adapt your experiment accordingly first until these resources become available. So all these kind of things kind of have an impact on this. Any questions so far? Now, based on this kind of understanding, requirements, topology, there are also different experimentation tools that can help you with. So this is something that will be covered in the second part. And you need to basically then select based on the testbed or based on what's your familiar you are with certain tools, or are you more comfortable with scripting. So this type of decisions you have to do. And then you need to configure your instrument, your experiment. This means instrumenting it. So the statistics that you want to collect, you may need to, for instance, embed certain logic in your experimental code that kind of computes the statistics, or at least collects a basic set of snapshots of the statistics that you can then export into a results repository during your experiment and analyze later. Also, you may want to have some certain controls of your experiment. Maybe you want some nodes to go up on a certain time or go down in a certain time. You may want to maybe inject certain events inside of your experiment. And although there are some facilities provided that can provide some form of, let's say, event injection or generation through external hardware that you can control, a lot will be also maybe implicitly done with some handlers that you embed in your code. So here you need to kind of implement, let's say, some commands that you want to receive, and then maybe then adapt your experimentation logic accordingly. So the testbed provides you with a bidirectional channel where you can interact with each node individually. So you can send commands and also receive statistics from it. And this is basically what it is exactly is something that you have to define. Now, after we've basically, let's say, understood our requirements, specified our experiment, hopefully have a working prototype of our whatever code or let's say system function logic we want to test, we need to then reserve experimentation resources accordingly. And then obviously deploy as well these experimentation resources on the different nodes or the different parts of the system that you want to look at. And for instance, in system level experimentation, you want to reprogram individual nodes. And you may want maybe to have one image per node that is exactly the same. Or you may also want to have maybe for different nodes that have different rows, different images, right? So again, you need to provision those onto the nodes, and the testbed gives you functionalities and the tools to do this automatically. But you need to still tell them and point them to the right images. So this type of stuff is something that you have to take into consideration. And then once basically you have the resources for you and they are available, you can then schedule or run the experiment. And currently in the testbed, a lot of this is done only when you have actually access to these resources. But also some options are for scripting clients currently that you can also automatically schedule the execution of the experiment in the future. So then, once your experiment is up and running, obviously for the experiment itself, the testbed provides you with a lot of primitives. So for instance, the testbed runtime allows you to flash, reset nodes, check if they are alive. This is something that you need to know. Also, it gives you basically like this bidirectional channel between each node and your experimentation endpoint. And this is called a controller in the testbed runtime terminology. Here you can basically get, let's say, messages from your experiment, which could be like debug messages that you define, or statistics that you collect, or you can also inject commands into it, so instructions that you want maybe when you coordinate an experiment. And obviously the logic of what is done, for instance, what kind of statistic you want to print or send back, you have to define. So you have to say, okay, you have to compute maybe this type of metrics on a node, inside of a node, and then send it back. There are certain primitives that allow you to send it back to the controller. You can, for instance, dump entire packets that you receive. Or you can just collect a particular statistics that you want and send it back. And also one of the issues here as well is the problem of implementing as well, let's say, some form of handler commands inside. So whatever, maybe you want, you may want to provision a node just to have your image just to have one particular code for all the nodes, but the rows can be switched, let's say a sync or standard node, and you can say, okay, now you're a sync, now you're a standard node. This type of logic you can then implement here and activate through commands. Another important aspect here as well is time synchronization. So there is basic time synchronization available. So on each of the gateway nodes. You have some form of network time protocol NTP that provides you a certain reference time. And obviously, you need to somehow also copy this timing or synchronize this timing with your sensor nodes that are attached. Then obviously all these different traces that are kind of generated from experiment, they end up in an experimentation repository. This is like an SQL-based database. We're quite flexible in how you want to populate it. It's just like it dumps basically one type of packet that you define, could be different types, into an experimentation repository. And then later you can process and analyze this with MATLAB scripts, for instance, or other Perl scripts, or whatever your way of working is best. And yeah, as I said, timestamping is important. And you need to take care of also having correct system times across different nodes, even across testbeds, if you involve different testbeds. And obviously also in your node, sometimes time may drift. This type of stuff you have to take into consideration. Yeah, and I think in the end, you can also analyze traces, extract statistics. Some metrics you may need to compute inside of your node, and because it's difficult otherwise to capture it. Others you can just post-process. So it's again up to whatever scenario it is, you need to take this into consideration. And we have, for instance, Timon offers, for instance, quite a nice, it's one of the tools, but like quite a nice architecture to get also some form of live feedback on what's happening in your testbed. So we have some tools that allow you to, for instance, view traces as they come along, data. So we have some plugin architecture where you can create visualizations. So you could, for instance, assign different color to different nodes in your configuration based on certain properties. You can see, for instance, as well how information flows through the network. So this type of things you can visualize flexibly with the plugin architecture that we offer. And you can also see live statistics in graphs and so on, just to get a feeling of how your experiment is performing and running. Obviously, if you have a very large data set over days, over months that you collect, this is something that you do offline. But still, I mean, especially during the early stages of your experiment, when you prototype still, it's very good, useful feedback tools to have. So you can see what's happening in your network. You can find bugs quicker for this, without wasting a lot of time running an experiment. Okay, so there's kind of like a brief overview of the overall experimentation life cycle that you're faced with as an experimenter, and what kind of things that you have to think about when you do experimentation. And then what we now look at is more in a typical experimentation life cycle. And I have to admit that the current thing is more focused now on systems level experiments where you actually have to interact with the actual nodes of your testbed, IoT nodes. I think in the tutorial this afternoon you will also learn a little bit more about service experimentation. So we have like three different like parallel sessions this afternoon. I'll talk a little bit more later about this. That look at the different testbeds, and they also kind of will teach you a bit more the tools that we just present now and how to use them and how to actually run an experiment. So as you can see here, overall we have some SmartSantander testbed runtime, and this is where basically this resides on the testbed server, and also this is something that resides on the gateway nodes that we got. So it's kind of a distributed kind of system in architecture, and obviously on the testbed server we expose certain APIs that can be used. So interfaces that can be used to interact with and to utilize the testbed functions. And throughout this project, the SmartSantander project, we developed overall, and also from Wiseman Legacy, we developed 3 different types of testbed clients that can connect to this SmartSantander testbed runtime, and it can then provide different types of views and functionality, look and feel, and of interacting with the testbed. And also you are free to extend this and implement your own tools if you like, or integrate this into your own tools if you like, because the APIs just wrap certain functions that you can then invoke I mean, in the way you would feel most comfortable with. So today we talk about this 3. So why is GUI, Timon, and the scripting client, which I guess is more that state of the art what we offer, and in future maybe you can also work on these extensions of it or build your own. I mean, it's up to you. So briefly just about Timon. So Timon is basically this graphical user interface. So it's a kind of, you could say it's basically, it appears like a simulator more than like a testbed management tool, but it provides you some form of graphical environment where you can have different things. So you can basically look at your testbed resources that you have available. You can understand the topology, so see what kind of nodes they are and how are they connected in terms of actual physical links. And also the quality of the links you can assess. You can through this then reserve certain nodes based on certain properties. And then obviously reprogram these nodes. You can control experiments for it. You have this plugin architecture I mentioned where you can quite flexibly build up visualizations for your experiment, so specific to your experiment and your demands. And believe me, every experiment is different, has different types of requirements. So you need this flexibility to be able to tweak, let's say, how you process this data, how you visualize it, to get the best out of what you want from the experiment. And you can also replay experiments as well. So for instance, you can have a whole trace collected in a database and then replay the visualization of it again. So it provides you with a way of studying as well at certain points your experiment and then maybe quicker debug any problems that you may have or gain an understanding for it. And this is supported on two sides, Guildford and Lübeck. Michele will dive into more detail about this in the session in the afternoon. I will just give you a very, very brief snapshot of a few things of Timon here. So Timon itself is basically supports you with all these different phases. So like the specification phase, also the execution phase of your testbed and provisioning. And what it does is basically obviously interacts with the testbed backends and also the testbed runtime to get for instance, reserve schedule resources and so on. Some unique features is that it provides some resource explorer and topology explorer. And this is drawn from, so you have each experimentation resource. If it's an IoT node, or is it like a phone or whatever, in essence it could be any type of IoT node, is described semantically in its capabilities. And then you can also then, let's say if you have a testbed with 1,000 nodes or 500 nodes, just having a list and all of these properties, it makes it very difficult to select what you need. So we offer some form of tools that allow you to easily semantically query what type of capabilities your testbed resources should have. And then we represent you with this type of resources it can do. So this is kind of a way of making it easier for you to interact with the resources. The topology explorer is also something special. So when we run continuously, when the testbed is operating, you can run, let's say, some form of basic link characterization. That kind of provides a snapshot of your current topology. And this type of information is then stored in some form of database that visualizes then the quality of the links and so on. And that can be pulled out to export topology. And then, of course, you have tools that then allow you to visualize and play around with the live experimentation data. So the Resource Explorer I just explained. So for instance, you can see there, whatever, on a flow already 100 different nodes. So maybe difficult to understand what each of them offers in terms of sensing capabilities, in terms of the types of hardware they got, in terms of maybe the deployment locations and so on. And you can easily, let's say, specify the type of resource, for instance, if it's currently reserved or not, and so on. So you can specify certain properties, and based on some semantic matchup, will deliver you the resource fulfilling these requirements. So it's kind of like a simplification step. It can save you a lot of time at the beginning. And also, there's another tool which allows you basically to understand the topology. And so, as I said, we have in the background we run different link characterization mechanisms, and so we measure, for instance, for each different channels that are possible, what is, for instance, for different power levels, what's the packet error rate, what's the LQI, what's the RSSI on average that you receive. So this gives you an understanding of how well the links are. Are they unidirectional? Are they bidirectional? Also, we look at interference levels as well, because our testbed is deployed in an office. There's Wi-Fi, there's Bluetooth, there's other basically, there are interference sources that are let's say in a live building available. You can also understand as well the interference levels of these. And maybe you can also, during an experiment, profile this interference and then understand, let's say, oh, actually, this link looked actually initially good, but somehow maybe someone turned on a Wi-Fi access point or did something, and this influenced actually the property of the link, and now it's only unidirectional, not anymore bidirectional. And this type of stuff you can actually catch out with this type of tools. So it's a quite useful thing to have, especially if you're interested in, let's say, more the networking type of research, topology, and the like. Okay, and we also have basically certain different visualization tools available. So, so you can see basically how packets travel live in an experiment in a particular topology. You can also look at basically different sensor readings or latency statistics that you compute. You can trace them live. You can see them as they come from the different controller instances delivered to you. You can track them and have a look at them. Or you can just look as well at the different raw logs that you look and receive. And as I said, you can also replay all these later. So it's, I think, a quite powerful environment to become productive quickly. Okay. That's, I think, as much as I want to say to Timon. Michele will have a very more in-depth look at it later with you, with a real practical example. But now we'll hand over to Daniel for the other two user interfaces, and I'll be back again for the user-centered experimentation part.